Let's begin with an object you know intimately. An object of simple, everyday utility, found in kitchens and cafes across the globe. Here's something to chew on. Take a teaspoon. Hold it in your mind's eye. Feel its familiar weight, its smooth, cool surface. It is a tool for measuring sugar, for stirring coffee, for sipping soup. It is mundane, it is normal. Now we are going to use this simple spoon for a thought experiment that will take us to the very edge of reality. We're not going to the pantry for a scoop of sugar. We're going on a journey across thousands of light years, to a cosmic graveyard where the laws of nature are pushed to their absolute breaking limits. Now imagine using our humble teaspoon to scoop up a tiny piece of a neutron star. This isn't just any star. To understand what we've just captured in our spoon, we have to rewind the clock. Imagine a star born with at least 10 times the mass of our own sun. For millions of years it lives a brilliant, furious life, fusing hydrogen into helium, then helium into carbon, and so on, forging heavier and heavier elements in its core. But this process has a fatal endpoint: iron. Unlike the lighter elements, fusing iron doesn't release energy, it consumes it. The star's internal furnace, which has held the crushing weight of its own gravity at bay for eons, suddenly switches off. In less than a second, the star's core, a ball of iron larger than our Earth, collapses in on itself. The outer layers, now unsupported, come crashing down at a quarter of the speed of light, only to rebound off the newly formed ultra-dense core in a cataclysmic explosion we call a supernova. What's left behind in the center of this cosmic violence is the star's ghost, a neutron star. It's one of the densest objects in the known universe. So, what does that teaspoonful of stellar remnant actually weigh? The answer is staggering. That single tiny spoonful of neutron star material would weigh about 6 billion tons. That's not a typo, 6 billion tons. To put that in perspective, that is more than the weight of every single man, woman, and child on Earth combined. It's the mass of all 70,000 of the world's largest aircraft carriers. It's the weight of the entire Great Pyramid of Giza multiplied by 1,000. All of that mass, all of that history, all of that sheer substance fits into a volume smaller than a sugar cube. How is this even possible? Because during the star's collapse, the gravitational pressure is so immense that it overcomes the fundamental forces that keep atoms apart. The vast emptiness within each atom vanishes. Electrons are smashed into protons, creating a substance made almost entirely of neutrons, packed together cheek by jowl. It's a material so dense it's essentially one giant atomic nucleus the size of a city, and its density is just the beginning of its strangeness. When the massive star collapsed, it conserved its angular momentum, just like an ice skater pulling in their arms to spin faster. This means neutron stars can rotate at incredible speeds, some spinning hundreds of times every second. They also inherit the star's magnetic field, concentrating it to a level that is trillions of times stronger than Earth's. This combination of rapid spin and intense magnetism turns many neutron stars into pulsars, cosmic lighthouses that sweep beams of radiation across the galaxy. If one of those beams happens to sweep past Earth, our radio telescopes detect a precise rhythmic pulse, the heartbeat of a dead star. This is the kind of physics that plays out in the cosmic arena every single day, operating on scales that really defy our everyday intuition and bend our minds into new and interesting shapes. The universe is filled with phenomena like this, objects and events so extreme they make our most solid realities seem like fleeting dreams. This mind-bending fact about the teaspoon isn't just a fun piece of trivia to share at a party. It's a key. It's a key that unlocks a fundamental and perhaps unsettling truth about our place in the cosmos. We live our lives governed by what feels normal, by the physics of our immediate environment. Gravity is a gentle force that keeps our feet on the ground. A rock is heavy, but we can lift it. The sky is up, the ground is down. Our entire civilization, our biology, our very consciousness is built upon the foundation of this terrestrial human-scale experience. But the universe doesn't care about our normal. Our normal is the exception, not the rule. The universe operates on a set of rules so extreme, so vast and so powerful that our entire planet is just a tiny, fragile exception. The rule of the universe is crushing gravity that can spaghettify planets. It's searing radiation from gamma-ray bursts that can sterilize entire solar systems from light years away. It's the unfathomable absolute zero cold of empty space. Our comfortable world, with its liquid water, breathable air, and gentle sun, is a tiny protected bubble, shielded by a delicate magnetic field and a whisper-thin atmosphere, floating in an ocean of cosmic energies that could obliterate it in a heartbeat. Think about that teaspoon again. It represents the raw, untamed nature of the cosmos. But here is where the story turns, where this terrifying object becomes something deeply personal. The very same forces that create an object as dense as a neutron star are the same forces that give us life. The Big Bang created hydrogen and helium, but almost every other element was forged in the heart of a star. The carbon that forms the backbone of our DNA, the oxygen we breathe, the nitrogen in our atmosphere, all were cooked up in stellar cores. But the story doesn't end there. Elements heavier than iron, like the gold in our jewelry, the silver in our electronics, the uranium that powers our cities, cannot be made in a normal star's life. They require the unimaginable energy and pressure found only in the most violent cosmic events, the explosion of a supernova, or the collision of two neutron stars. The forces that create that teaspoon of dense matter are the same forces that forge and scatter the precious, heavy elements across the galaxy. The iron in your blood, the calcium in your bones, it was all cooked up in the heart of a star that lived and died long before our sun was even a twinkle in the galaxy's eye. We are, in the most literal and profound sense, stardust. We are the children of cosmic explosions. The universe is not just something out there, it is within us. Every atom in our bodies, aside from the primordial hydrogen, has a stellar birth certificate. So, when we look up at the night sky, we are not just looking at distant twinkling lights. We are looking at the grand, cosmic furnace that created us. We are looking at our own extended family history, written in fire and gravity across billions of light years. It's a humbling and exhilarating thought all at once. It connects us to the grandest story of all. This realization changes everything. It changes the very nature of our questions. We move from asking the simple question, what is the universe, to a much deeper one. What is our relationship to the universe? It reframes our entire existence from being passive observers to active participants. We are not separate from the cosmos, looking in from the outside through a window. We are a part of it, a thinking, feeling, questioning part of it. We are, in a very real sense, the universe's way of becoming aware of itself. And that brings us to the biggest, most tantalizing question of all, a question that has haunted philosophers, scientists, and dreamers for centuries, a question born from this very realization of our cosmic origins. If the ingredients that made us, the carbon, the oxygen, the iron, are scattered everywhere, forged and distributed by billions of supernovae across cosmic history, and if the same physical laws that govern our existence apply everywhere, then is it possible that this miracle of consciousness has happened before? Is anyone else out there looking back at us, asking the same questions? Are we alone? The answer, whatever it may be, is the most profound truth we could ever discover. Either we are a singular, precious miracle in an empty cosmos, the universe's sole voice, or we are just one voice in a grand, cosmic chorus. Either way, the story is just beginning.